Okay, today we're going to be talking about so proportions are two ratios together that are equivalent or the same. So we're going to look at the ratios 2 to 7 and 6 to 21. We want to know if they are equivalent. Okay, so one way to do this is you can simplify your ratios so that they're in simplest form and then compare your simplest form. So is 2 to 7 already in simplest form?
Yes.
Yes, it is. Is 6 to 21 in simplest form?
No.
No, it's not. What do they share?
3.
3. 6 divided by 3 is? 21 divided by 3 is?
7.
7. How do those two ratios now compare?
They're equal.
They're equal. Therefore, are 2 to 7 and 6 to 21 proportional? Yes. If in simplest form, if they match each other, then you would say yes, they are proportional because 2 to 7 is the same thing as 6 to 21 when 6 to 21 is in simplest form. Okay? Look at the next one. 8 to 24 and 6 to 20. Is 8 to 24 and 6 to 20 in simplest form? No. 8 to 24 can be divided by 8, which simplifies to 1 to 3. 6 to 20 can be divided by 3 over 10. Are these two ratios proportional? No. You would say they are not proportional. 8 to 24 does not equal 6 to 20. So no, they are not proportional. Okay, so that's one way you can do it. There's another way we can do it is we can do cross multiplication. For example, if we had 2 to 7 and 6 to 21, if two ratios are proportional, their cross products, these two numbers across from each other multiplied together, should equal the same product as these two multiplied together. So what is 2 times 21? 42, right? What is 7 times 6? 42. Are these proportional? Yes, because the cross products equal the same number, 42. Okay, look at the next one. 8 to 24, we already know that it is not proportional to 6 to 20. But I want to show you how cross multiplying works. What is this cross product? 20 and 8. Okay, 160. What is the cross product of 6 and 24? You can do the break apart strategy. Go 20 times 6, 120. Go 4 times 6, which is 24. Go 120 plus 24 is 144. Do they equal each other? No. You would say not proportional. All right, look at the next one. It says you can compare ratios using a common denominator as well. It says use the data in the table to determine whether the ratios of oats to water are proportional for both servings of oatmeal. Write the ratios of oats to water for 8 servings and then again for 12 servings. The ratio of oats to water for 8 servings, so we're looking here, is going to be 2 cups of oats to what? 2 cups of oats to 4 cups of water. So this ratio stands for that, 2 cups of oats to 4 cups of water. I also want to know what the oats to water ratio is for 12 servings. And it needs to line up. If we put oats on top on the first one, then that means we need to put oats on top for the second one. So how many cups of oats is needed for 12 servings? 3. To how many cups of water? 6. So we want to see if 2 to 4 and 3 to 6 are equivalent. So what they did, if you look here, they did a common denominator for 4 and 6, which is 24. So they went 4 times 6 is 24, 2 times 6 is 12. So they got 12 to 24. 3 to 6, go multiply by 4, multiply by 4, and you get 12 to 24. Are those two servings, an eight servings thing of oatmeal and a 12 servings thing of oatmeal, are they proportional? Yeah, because with a common denominator, they are the same ratio. Okay. All right, look at this next one. Okay, the next one says find a ratio equivalent to each ratio, then use the ratios to write a proportion. Okay, 1 to 3. What is a ratio that is equivalent? What is the ratio that is equivalent to 1 to 3? Madison? Good, because what did you do to both the first term and the second term? Good, you went multiply by 3, multiply by 3. So then that answers this part, right? Find a ratio equivalent to each ratio. But then it says use the ratios to write a proportion. What does that mean? This is all they want you to do. They just want you to write that 1 to 3 is proportional to 3 to 9. That's all it means, is that you're just writing an equal sign between those two ratios to show that they are proportional. What about 9 to 21? Would be proportional to what?
37.
Okay? What about this one? Would 18 to 42 work?
Yeah,
Why?
because they're timing them by the same number.
Both by 2. So either one would work. 3 to 7 would work, and 18 to 42 would work. They're still proportional. What about 8 to 3? This might look weird to you because what does it kind of look like? 8 to 3 looks like a improper fraction, but are we doing fractions? No, we're doing ratios. This is like saying, maybe we're doing a pet store and we have 8 cats to 3 birds. Is that okay? Yeah, that's fine. You can write it this way with the bigger number as your first term. Do not flip it. Do not flip it. You leave it the way it is. If I did an equivalent ratio, can I say 16 over 6? Yeah, because I multiplied both the first term and the second term by what number? 2. What about this one? If I would have said 24 to 12. Is that proportional? Why is it not proportional? You're right. It's not proportional.
The bottom one by 4 and the top one by 3.
My first term I multiplied by 3. My second term I multiplied by 4. If you are multiplying by a different number, you are not creating an equivalent ratio. This would be wrong. Are there any questions on how to do that? Okay. All right, you might also have problems that look like this where it says complete each table of equivalent ratios. They are telling you that these, which are all first terms, are equivalent to each other, and all these numbers are the second term. So like this would be 1 ratio here, this would be 1 ratio here. What would this missing number be for tigerfish? If it was 4 to what is equivalent to 8 to 6?
4 to 3 is the first.
How do you know it's 3?
Because divided by 2.
Yeah, I'm working this way, and I say 8 divided by 2, 6 divided by 2. What about this one?
24.
Yeah, because you go 6 times 3 to get to 18. Go 8 times 3 should be 24. What would this missing term be?
20 over 14.
Don't do any minusing. You can only do multiplying and dividing. Now ask yourself, does 24 go evenly into 20? Does 8 go evenly into 20? No. Can I use my 4 to 3 ratio instead? And go 4 to 3 is equivalent to 20 to what? And say 4 times 5? 4 times 5 is 20, and 3 times 5 is?
15.
So do you see why you have to go back and sometimes use a different ratio? Because some terms will not always go into the other terms. If that happens, let's say that they only gave you 24 to 18. is equivalent to 20 over something. But 24 doesn't go into 20. Can I use cross multiplication? Can I say 18 times 20? Which would be what?
360.
360, and then divide it by 24? Yeah. Mm-hmm. And then you would get a number for x, like how many tiger fish would that be? So go 360 divided by 24. And you should get 15 equals x.
360 divided by
24.
I got 15.
Good.
Ben, we already have that.
No, it's okay. All right, look at the next section. It says find two ratios equivalent to each given ratio. There are three ways that ratios are written. One way is with words, by saying 3, 2, 7 with the word 2. Another way to write a ratio is to separate your first term and your second term using a colon. Do you see how they do that in 32?
Yeah.
How do you read this? You read it as 6 to 2.
So it'd be like a 6.
Yep. Or you can read it in fraction form, which is A over B. There are three ways to write ratios. Do you see how you do all three? On number 1, which one is your first term? 3 is. What's your second term? 7. So if I'm doing an equivalent ratio, I would suggest setting it up in fraction form so you can easily see how you convert. What would be an equivalent ratio?
6 21st. I mean, no.
Times by 2 times by 2. 6 to 14? Okay. Look at 32. What is your first term? 6. Put that on top. What's your second term? 2. What would be an equivalent ratio? 12 to 4. Don't read it like a fraction. Don't say 12 fourths. Read it as 12 to 4. And then 5 to 12, an equivalent ratio could be what?
10 24th.
Multiply by 2, 10 to 24. Okay? Let's look at number 9. It says if you recycle one aluminum can, you can save enough energy to run a TV for 4 hours. One aluminum can to run a TV for 4 hours. Write the ratio of cans to hours. So I would write number 9, A. What do I want as my first term?
2080.
What do I want as my first term? Cans.
How many?
Cans over hours. And the reason I know that is what's the first thing they tell me? Cans. And here's that clue word for ratio, 2. Second term? Hours. How many cans? How many cans? Okay, just use the information that's here. One aluminum can. One can for what time? And it must be in hours, because that's what it asks for. So I would say 1 can to 4 hours. Then it says, Marty's class recycled enough aluminum cans to run a TV for 2,080 hours. Did the class recycle 545 cans? Justify your answer using equivalent ratios. What do you ask to find?
How many cans it takes to run 2,080 hours?
Okay, so let's do that. Number of cans needed for 2,080 hours. And then I'm going to compare to what number?
545.
Yep, 545, because it says, did the class recycle 545 cans? So we're going to compare once we figure it out. We're going to use this ratio, because I know that for 1 can, it can do a TV for 4 hours. Right?
500.
Stay with me. I'm going to create a ratio. 1 can for 4 hours equals, what information do I know? Number of cans or number of hours? Number of hours. So I'm going to put 2,080 hours lined up to 4. Do you see hours lined up to hours? I'm going to solve for cans on top. Cross multiply. 2,080 times 1, 2,080, divided by 4.
520.
Yep, 520. So we determined that they do 500, they would know that 520 cans would power a TV for 2,080 hours. But Did the class recycle 545 cans?
No.
You would say no, because to run a TV for 2,080 hours, I would have to recycle 520 cans, which is less than 545 cans. Do you see how you include that whole answer? That's what you need to do. I want to do one more. Let me see if I can erase a spot here to work.
86 days if they ran that TV. Full 24-hour days.
Pretty crazy. It's a long time. Okay. Is it number 20? No. Number 40. Okay, critical thinking. It says the ratio of girls to boys riding a bus is 15 to 12. So my first term stands for who? Girls. My second term stands for boys. So 15 girls to 12 boys. If the driver drops off the same number of girls as boys at the next stop, does the ratio of girls to boys remain 15 to 12? Explain. What do you think?
Yes.
Would the ratio stay the same? If the bus driver drops off the same number of boys as the same number of girls, would it stay the same?
No.
Let's try it.
Yes, it would.
If you're not sure, try it. Let's just say, so we have 15 girls to 12 boys. If the bus driver drops off, let's say he drops off 2 and 2, because the same number of girls will get off the bus and the same number of boys will get off the bus. So let's say that 2 get off, which changes my ratio to what? 13 to 10. Can we decide if 15 to 12 is equivalent to 13 to 10? How can we do that? Cross products? 15 times 10 is what? What's 13 times 12? 120 and 36, 155?
156.
156? Are they equivalent? No, they're not. So to answer the question, if the driver drops off the same number of girls as boys at the next stop, does the ratio of girls to boys remain the same?
No.
You would say no, and you can show an example. For example, if 2 girls get off the bus, your first term would now be 13. If 2 boys get off the bus, you now have 10. 13 to 10 is not proportional to 15 to 12.
Darn it.
If you're ever not sure, what should you do?
Try it.
Just try it out. Take a couple away, test drive it, see if it works. Are there any questions on this? Okay, on your assignments, the directions say